Hello, everyone, and welcome to the Canadian Electricity Association's Conversation webinar series. My name is Dave McKendry. I'm Senior Fellow with the Canadian Electricity Association. I'm pleased to be your host for today's session. The CEA has been working with our corporate partners to develop this conversation series, which focuses on solutions to current and future challenges faced by our industry. Today, Southern California Edison and Infosys will be presenting technology solutions in the grid modernization journey for electric utilities. The future of electric utilities is carbon neutrality. This means replacing non-renewable and centralized generation sources with renewable distributed energy generation sources across the electric grid. Many states in North America have already defined aggressive goals of carbon-free electricity in the next few decades. This requires an overhaul of our approach of how we plan and engineer the grid for a long time and how we will operate it in real time. This demands new systems with capabilities to plan and operate an electric grid powered by distributed generation. We have three presenters today. With over 5 million customers, Southern California Edison's Michael Schulte is a principal manager and has been leading the IT solution delivery organization for SCE's Grid Modernization program for the past 5 years. Prior to that, Mike worked on smart meter system deployment, product management, and field deployment for 2 major electric utilities in California. Mike has 30 years of utility experience, both in industry and as a consultant. Shobha Tanetti has over 25 years of IT experience. She is the IT release manager for the Grid Modernization Engineering and Planning portfolio at SCE. Shobha's prior roles included leading IT service management and serving as an IT specialist. Before joining SCE, Shobha was manager with CSC, leading an IT team at the San Onofre Nuclear Generation Station. Raj Chatterjee is a senior principal at Infosys Consulting with close to 18 years of experience in the utilities industry. He's been playing the role of solution integration lead at SCE's Grid Modernization program for the last 3 years. Prior to this, he led multiple transformational programs in the transmission and distribution domains of utilities. Before we get started, we'd ask that you please feel free to enter any questions you may have into the chat feature on your webinar screen, and we'll get to those questions at the end of the webinar. We will be sending out copies of this presentation along with a post-webinar survey, and we certainly appreciate your feedback. And we're also interested in any topics that you may be interested in seeing as a part of this conversation series. With that, Mike, we'll now ask you to come on screen and we'll turn the webinar over to you.
Thank you, David, and good morning, everyone. Greetings from Los Angeles. I hope you can hear me well. One quick note on the speakers this morning. We'll be talking about our grid modernization program, the impacts on the business, the value proposition to the business. However, our background and our careers are in IT. We're representing the IT portion of that program. So there'll be a little bit of a slant in terms of some of the IT lessons learned, some of the program lessons learned, but I think we also will kind of transcend that particular narrow focus and talk more broadly about the business. But I did want to touch a little bit on our background from that perspective. So let me start off by talking a little bit about SCE's Grid Modernization program. So it has been a strategic initiative of SCE since about the 2015-2016 timeframe. It is a cross-organizational initiative that includes both IT and transmission and distribution, the T&D organization, and represents a very significant investment, a multi-year investment that we'll start talking about the different portfolios that represents in upcoming slides. Let me go now to talk about some of the drivers to grid modernization. On the left of the slide, there is a list of some of the actually legislative mandates that were key drivers to this program. And much of them are pretty well known. Maybe not the specific legislation, but the idea that there are very significant, very ambitious renewable goals in California, 50% of renewable portfolio standard by 2030 being one, renewable energy and zero carbon resources supplying 100% of the electric retail sales and end use customers by 2045. Those are a couple of the highlights. I think it's pretty well known that California is leading the way here and has set fairly ambitious legislative targets around greenhouse gas reduction and moving and decarbonizing the environment. There is a regulatory component to that called the Distribution Resource Plan, which is a little bit more targeted to what we're going to talk about this morning. And that's really how to enable distributed energy resources, renewable resources, energy storage, to be a part of the operational environment and the market in achieving those greenhouse gas goals and those renewable resource goals. So what you'll hear today is really a focus on enabling how Edison is making investments and developing capabilities to enable that distributed energy resource participants in the market to really grow and proliferate. And that kind of takes us to the middle of the slide where you can see the increasing grid complexity. You'll see solar there, batteries there. That's the DER component to it. And of course, it's, there are other factors that are increasing the complexity of our operating environment, of the market environment. Certainly the move from a very, as David alluded to, from a very centralized supply side feeding into a broad distribution network is something that we're evolving very quickly away from in the advent of DERs and the kind of the distributed nature of that DER portion of our portfolio. And then finally, customer choice and reliability. There's a lot of different flavors of that. You can see in the slide that transportation electrification is another key initiative at SoCal Edison. We have the complexity right now of dealing with wildfire challenges and the use of public safety power shutoff to mitigate some of those impacts. So it's a very complex picture. Reliability is one of our key objectives, and that customer choice component is very important in this particular case around thinking about the customer in the form of the distributed energy resource customer. Next slide. So let me focus on that first sentence in the takeaway box at the top. So it's increasing DER portfolio dependability and participation, as I've been saying, by integrating DERs into planning and operations. So our grid modernization program has a very clear planning side to it and an operational side to it. This presentation will focus primarily on the planning side, how we're enabling DERs to be more tuned in and a more direct participant in how we plan out our distribution system in particular. However, Grid Mod, SC's Grid Mod program, has a very significant operational side to it as well. And I'll talk about that in a little bit more detail in the next slide, I believe. However, in terms of objectives, at a high level, it's pretty effective to think about grid modernization in terms of enabling four key capabilities: enhancing our monitoring capability, our analyze capability, our optimization capability, and our control capability. Monitoring and control, again, are a little bit more on the operations side. So again, the focus of our discussion is going to be a little bit more on the analyze and optimize, and specifically things like load and voltage profiling, things like long-term forecasting, is really some of the tools and capabilities that Raj will be getting into in much greater detail in the upcoming slides, as well as optimize. So using those tools to develop a very accurate and precise integration capacity analysis. And we'll talk later about what that is. Using power flow analysis that incorporates DERs into that analysis in order to produce long-term plans, long-term distribution plans that take into account DERs as part of the market, as part of the operating environment. So I wanted to just focus on really those are two of the key objectives at this high level that we're going after with, in particular with the investments around the planning side of grid modernization. Next slide. So let's talk about the components of the program and give you all a feel for how we've structured our program here. The engineering and planning tools, again, will be the focus of this presentation. So I'll leave those to last. And let's just touch on some of the other areas of the program to give you a feel of what the comprehensive program's about. First is grid automation. And I said that Grid Mod is an integrated program crossing both IT and T&D. Well, the T&D investments are really specifically in grid automation. And the best example of that is on the distribution automation side, where they're investing in smart grid devices, remote control switches, remote fault indicators, those kinds of devices that go on the grid itself and are sending back better information to SCE and to our data center. In order to do that, I jumped down to number 4. One of our key investments is going to be a new field area network. So that very significant investment to enable the communication network to support that kind of distribution or that kind of implementation of smart grid devices on the field, as well as some of the grid operational benefits that we're looking for with grid modernization. You need a very robust, low latency communication network to support that, and that's what number 4 is. Underlying all of that is enhanced cybersecurity, number 5. So we're expecting to bring back much more information and data from the field, from outside of our network, including from third parties. By definition, the vast majority of the DERs will be third parties. That requires a new set of cyber tools and an advancement in our cybersecurity. And we're making that investment in our new grid data center to make sure that we've got the cybersecurity underlying a lot of this communication and control activity that we are looking to achieve. And finally, to jump back to number 3 are the grid operational tools. So that's the operations side of it. And really what that is an advanced distribution management system, ADMS. We're implementing that over the next few years, as well as a DER management system, a DERM system. So really the next generation of our grid operating systems or grid management systems is also part of this grid modernization portfolio, and really the heart of the operations side of the program. Now tracking back to what our focus is this morning, engineering and planning tools. That's a set of about a half dozen solutions really targeted at enhancing our forecasting ability, our profiling capability, and the way that we communicate with these customers, both through the DER external portal, which Raj will be demoing, as well as an enhanced tool for automating the interconnection application process, which has been another hindrance to DERs being able to really be active in the market. So more to come on those. That's a high-level flyover of the tools, and as well as the overall set of investments that comprise the Grid Modernization program at SoCal Edison. Next slide. And then finally, before I hand it over, just to focus on benefits. Again, these benefits cross the entire program. So you'll see those that really apply more to the operational side. We've highlighted those in blue that really, again, focus on the engineering and planning tools, focus on the planning side of our range of benefits that we're pursuing. I'll call your attention to really the two marked in blue at the bottom of the slide, which again, really just picking up on that same theme. What we're looking to do under customer empowerment, provide more DER opportunities through grid planning transparency. So hopefully you'll, as you go down into the details and Raj takes you through the specifics of the tools and a short demo, you can see how we're tying back to providing DER opportunities through this transparency. And then finally, the end result of incorporating these enhanced tools into our annual distribution planning process is to get to that optimized decision around what the right investment is holistically. And inserting the opportunity and the option of identifying DERs to meet needs, as opposed to kind of the legacy approach of just making more grid upgrades, the utility making more distribution grid investments, being able to expand that analysis, being able to expand that forecast to more holistically think about how DERs can serve that purpose. So with that, I'll hand it over to Raj, who will dive down a little bit deeper into some of the specific drivers to the program from kind of a duck curve perspective, and then talk about the solutions themselves.
Yeah, thank you, Mike. Okay, so in this section of the presentation, we're going to focus very much on the engineering and planning side of the grid modernization. Considering the wider audience here, we'll just illustrate first what is the thinking process here, how DERs, instead of being a challenge in operating the grid, can be a solution here. So I'll use this duck curve as a quick demonstration of what is the thinking process behind the entire DER solution. So we are showing here just a load profile at a substation, which is 6612 kV. It's a forecasted load profile. Maybe 5 years down the line, we are seeing that the load or the energy needs have crossed the capacity rating of that substation. And in a typical world, what we would do is we would use a wired solution. We would try to increase the capacity of that substation to meet the increasing demands here. But here we're going to show how the DER solution, along with the other levers we have with the utilities, can help be a substitute to that typical capital solution. So this is just the forecasted load profile showing it's going beyond the capacity rating of the substation. And this is probably a cumulative effect of the DERs for that substation. We see that the peak overall consumption is coming down just through the use of solar PVs across the network. And this is called the net load profile. And this is already we are seeing today because of the DERs available across board around the territory. So there is already we can see shaving of the load to an extent. And next, we can possibly use energy efficiency programs to bring the overall load curve down. So this is how we're trying to show that how the original forecasted load can be brought closer to the capacity rating of the substation. So this helps take the next step, move it closer to the capacity rating. Next, we are going to use a demand response impact. If we have DR programs that helps shave the peak of the load profile where the maximum usage is, that helps bring it closer to the capacity rating. but it's still beyond the capacity rating. That's where we can possibly use energy storage to shave off the peak there and still bring it at par with the capacity rating. So this is just to illustrate the thinking process here, like how a DER solution can be used instead of a capital solution to meet the future demands of the grid. And this is the net profile. That was our original goal. Without using a capital solution, we are able, through these different levers that we are showing here, we are able to uh, meet the future demand here and within the current capacity rating. And as you can see at the bottom, these are basically hourly data. So this is a time series profile that we use to demonstrate the thinking here. So this is what we are going to show in the upcoming slides, how we are going to achieve this goal through changes in process and with new tools. So here we are focusing primarily on the long-term planning process. This is the annual system planning process. So how is this changing with grid modernization? This has been around with utilities forever, but what are we doing differently here? So what we are trying to do here is, instead of looking at monthly peaks and trying to use very minimal data, we have created 8760 time series profiles for each and every node in the circuit. We have started with the substations and circuits, and we are looking at hourly data for the last 10 years across the territory, and we are analyzing that. So the first step in this whole process, what we are doing is profile analysis and cleansing. We have first gathered this hourly data from the SCADA nodes and the AMI nodes, and we have collected all this in a huge data lake, which are time series data. Then we're using machine cleansing algorithms here to make these profiles as close to real as possible. We are trying to also capture the gross profiles and net profiles. We are using the DER generation profiles at each node to come up with the net profiles like we saw there. And after we have done a machine cleansing, which takes hours and days to begin with, it is handed over to the engineering group. They're looking at these profiles, they're reviewing, they are still able to manually cleanse this as needed to make it as accurate as possible. This helps us create the base for the entire long-term planning process. Next, we are using this net and gross profiles that we have created for the past 10 years to come up with a forecast for the future 10 years. So we are using another tool set for forecasting that helps us come up with different scenario analysis. This becomes the base of any future analysis, capacity analysis that we're going to talk about next. Uh, the forecasting system provides the most accurate forecasting information based on the historical data that we got from the profiles after the cleansing. We are using other parameters like weather data. We're using load growth information as much as we have. We know the queued DERs in the system, what is going to be the DER growth scenario. We are using econometric data. There's a bunch of parameters we are using to come up with the forecast as close as possible. Our entire assessment is based on the accuracy of this forecast that we built here. Next is capacity analysis. We are using the forecast that we just built, and we're using engineering tools to see where are the overloads. What sort of wired and non-wired solutions can be used? Can we use load swapping? Can we use load transfers? Can we use DR solutions anywhere? So all this analysis is getting captured in our engineering tools. And we are also, as you can see, we are using duct bank analysis, which also talks about the temperature overload states. That is also an important part of the capacity analysis we are doing. After the capacity analysis, the remaining sort of analysis, we have not listed on everything here, but some of the key ones are contingency analysis, fault for analysis, protection analysis, reliability analysis. All that has to be done, and different scenarios are looked at before the engineers come up with a set of projects that they would propose as mitigations to the future overload scenarios. And finally, we are looking at the portfolio of projects here that provides capital and non-capital solutions. We put priorities around that. This is also shared in public portals with DER aggregators to propose projects that could meet and kind of be replacement to the capital projects that we are seeing as a result of this analysis. Now, moving on to achieve all this. So I talked more about the process in the last slide. To achieve all this, we have created the half a dozen tracks that Mike mentioned earlier. These are the different tool sets we are using. The first one is a very key one, which is the grid connectivity model. This is basically building a network model all the way starting from the A station to the meter. Now, this is something that cannot be achieved at the first go. So we have started with the distribution side. We have created the as-built version of the distribution side without the secondary portion of it. We are adding the secondary portion to it now, which means the meters, the secondary network, and DERs. We are now also adding the trans-sub that is coming up in the future releases. You can see like the blue boxes is something that we have already built. Actually, the as-built subtrans is something we're in progress, and the remainings are still, we are in the process of building that. So once we're able to come up with the as-built connectivity, we're going to focus on the as planned, as forecasted versions of that model, because as we keep on adding projects, the model itself changes. So any future analysis needs to consider those future changes for forecasting or for any assessment. Grid Analytics is our base platform for any data algorithms, any data analysis that we need to do. This is where most of our profiles, cleansing, machine algorithms are used. We have started with collection of the raw data, like I said, SCADA, AMI, weather. We have built cleansing algorithms over the year that has changed and evolved over time. And this provides the base data, foundational data for us to do which is the third track, which is the forecasting. So forecasting is again a set of tool set. It still comes under analytics, but we have a separate tool set to come up with different scenarios of forecasting, for load forecasting, for DER forecasting, and they have the IPR aggregation also that we use. So this becomes the input for our system analysis process. This is where we are using engineering tools. There are multiple engineering tools across the industry that can be used for this. We are using this to come up with a capacity analysis, substation a capacity analysis, duct bank analysis, volt var analysis. So these are very specific engineering tools. We have some challenges about on the scalability front, but that is something we are working on right now to apply to the time series profiles that we are using right now. So after that, once we are able to do the base analysis, engineering analysis, we come to the grid optimized grid solutions. This is where we propose all the projects, all the mitigations, and there's a lot of risk analysis that happens here, prioritization, and finally all this information gets published into an external portal. Not all, I would say all the information that is necessary for the third parties and public consumers to use to come up with DER solutions. So as you can see, the basic information is integration capacity analysis, grid needs analysis, DDOR, locational net benefit analysis. All this is published in the portal, which I will show to you shortly in the presentation. This is just a bunch of capabilities that we are showing across 6 tracks that helps us meet the goals that we talked about in the previous slide. This is just a view of the conceptual architecture. You are now already familiar with the different 6 tracks we talked about. What we are trying to show here is this is all sitting on a huge data lake that we have to build, where we have to pull in all the raw data from different sources. Most of the data algorithms are used here to come up with the cleansing, with the massaging of the data that is required as inputs for most of the analysis. I will not go into much details unless we have questions later, but this is a conceptual architecture that shows how we are using all this data to come up with all the assessments that we are trying to achieve. And finally, I'll do a very quick demo before I hand it over to Shobha. Now, this is the DRPP portal for Southern California Edison. It's distribution resources portal, external portal. So I'm going to show you here what sort of information we are publishing. So I'm just giving a city where the Edison headquarters are, Rosemead. It takes us directly to that location. Now, by default, what you are seeing here are circuit segments. And it also shows what is the state of that segment. This is for integration capacity analysis. So if I just click on any one of these segments, let's say I clicked on a green one. So this gives the section ID. It also tells us about how much photovoltaic is being used, how much operational flexibility is there. It shows the circuit and substation that feeds it. It talks about the total generation there and how much queued generation is there. So right now there's no queued generation on this one. It shows the distribution of load here. So all this is being showed with the purpose. Let me show the load profiles. All this is being showed with the purpose that if, let's say, I had picked a red one, what sort of DR solutions would be needed that I showed earlier with the duck curve that could help us mitigate some of the future demands. Because the red ones, I'll show another one quickly. So this gives a very detailed information for that particular circuit segment on that city. So this is very detailed information that is available publicly for third-party aggregators and DR solutions to come in and propose solutions that can help mitigate the load requirements. All this can be also downloaded. That is the next step. Similar thing, if I show here on the red segment, you can see there is right now no DR queued here. Yeah, this is very little queued. So what it means is there is a lot of additional DR scope here that could be added, and that gives indication to the third-party aggregators that DR solutions can come in. This is called ICA circuit segment, which is the integration capacity analysis. Now, this is just one of the layers that we have in the portal. I'm just giving a very quick overview. This is publicly available. Once this presentation is shared, you can explore yourself. So it gives a lot of information about the GNA subtransmission. This is basically the grid needs analysis where all the substations are close to their capacity. It shows the deficiency percentages. Then the DDoR substations, which is the distribution deferral opportunity report where the DR solutions can come in. We also have the LNBA for short term, which is the locational net benefit analysis, net benefit analysis for short term, mid term, and long term. This is available at the substation level, at the circuits level. And finally, we have the DER growth scenario planning. So all these are different layers here, which are available at different zoom in levels. And there is very good help guide for anyone to refer if someone needs to dig in deeper. But what I'm trying to share here is all the analysis that we showed in the previous slides, like the integration capacity analysis, which is built on top of the forecasted profiles, as well as the network that we are building as part of the entire capability set. So those results, a subset of those results are getting published here so that third-party aggregators and other DR solution providers, they can come in and provide solutions that will help utility like SCE not use a capital solution, which can be taken off the rate case, but instead substituted with a DR solution. So all this is enabled through this portal, and it has a lot of information to do that assessment by any third party here. So with that, I'll hand it over to Shobha.
Thank you, Raj. Good morning, good afternoon, and good evening, everyone, depending on where you are. So Mike and Raj have provided us an insight into Southern California's journey to modernize our grid, specifically with respect to the engineering and planning tools. So it's time for us to talk about some of the challenges we have faced and the mitigations that can be considered. So as you probably got a feel of this, grid modernization, specifically with these tools, is pretty complex, emerging technologies, and we're talking about future-looking and next-generation capabilities. So it's important for us to position ourselves to be able to successfully execute the grid modernization program, given that we are exploring like a new analytics territory. So this requires new approach, new thinking, all the way from requirements gathering stage to delivering these capabilities. So to that end, we wanted to share our learnings and our recommendations with all of you prior to taking up similar very complex initiatives. So as we all know, our journey to something like this starts with a roadmap followed by requirements. So the challenge we have faced in our initial releases is that the scope has changed drastically over a period of time. This is because the analytical solution outputs needs to be reviewed by the stakeholders, understood by them throughout the life cycle, rather than just them seeing the output at the end of close to deploying the capabilities. So choosing the right methodology is key to success. So what we are recommending is that starting the process in iterations to deliver MVPs quickly so the business can and the stakeholders can look at the outputs and make the adjustments in the scope as we go along. So we could use CRISP-DM for analytics solutions that we have deployed successfully, or use of any agile methodologies, or even prototyping in any iterative process is going to really help the stakeholders and mitigate the risk of this scope changing from the beginning all the way to the end. So we are not recommending going through an elaborate requirements gathering process in the beginning, rather just start to deliver in an iterative fashion so that the stakeholders can adjust the scope based on the emerging thought process or the need. And as Raj already alluded to, data is the most important piece that we need to keep in mind. Most of the challenges come with the data. So when we usually start projects or programs, we initially start to think about the functionality. What is the functionality that we need to deliver? And then start to look at how do we design. But keeping the data in mind is very important. Specifically for grid modernization, we need to spend a considerable amount of time in the data realm. So the challenge we have faced at SC is that we identified that data sets that are needed a little later in the program that caused us some schedule pressures and cost pressures. So what we are saying is that let's start thinking about few key questions in the beginning, like what is the data sets, what are the data sets that are required? Where are these, what are the data sources? And how do we organize this data once we gather? So the first step is to identify the data sets. So for example, we might need 10 years of SCADA data or AMI data. We may need weather data, like Raj has already alluded to, or economic data. So we need to establish data sources once we identify these. And sometimes the data sources are internal and some are external. So we need to figure it all out. Where are we going to get this data? And then collect all of this data, consolidate, and build maybe a data warehouse in a big data platform so that we can prepare the data, organize the data, and this helps the analytical models easy access to the data and mitigate any performance risks in the future as well. So it's a very key area, and we recommend planning and developing that foundational data early on before we jump into the capabilities so that we have a good success path to deliver these capabilities, complex capabilities that we're talking here. So the next challenge is once we establish the data, what about data quality, right? So in the utility industry, we are already very familiar with the data quality issues all over. So like Raj alluded to, this data quality challenge is amplified with the time series data. So we are talking about a lot of data. For example, 10 years worth of SCADA data we may have, but when you look into a device level, when you go down to that lowest level, we may find that, for example, a 2-week gap in the data, or some very, very detail level gaps. And we faced with respect to the weather data at a specific weather station level, there were some data gaps for specific time periods. So we need to address that, and that will only come when we look at the data quality of the data that we have collected and uncover these data gaps at the lowest level before we start to work on the capabilities. So the question is, how do we mitigate these challenges, right? So we need to start building the data quality dashboards early on, identify the data gaps sooner than later, and sometimes, or most of the times, fixing the data quality issues may need more investments, because it could mean establishing a new business process, or it could mean re-engineering of the existing processes. So that might require investments and time commitments. So we need to keep all of those things in mind and see what is the data that we can fix. And the data that we cannot fix will be flowing into the solution as a scope, because the solution now need to address that quality issue, because we may not be able to fix it. So we need to keep that in mind early on, and otherwise those data gaps will keep coming as changes into the solution and put more pressure on, like I said, investments or even schedules. So focusing on the establishing a data quality strategy is very important and very key to rolling out of all these tools that we just talked about. Now, moving on to the next challenge, as you can see, is sizing of the infrastructure and the environments. So it's very important early on to keep a focus on this area. Again, this is because we are dealing with the time series data here. So the analytics algorithms that Raj has gone through need horsepower to crunch all of this data and provide us the results that we need. So just to give you an idea of what we are talking about when we say time series data is, if we have a utility with about 5 million AMI and 5,000 SCADA nodes, it generates about 200 billion records per year. So I just want to repeat, it generates 200 billion records per year. And in terms of storage, if we consider a 10 years of historical data for 10-year forecast, it would amount to approximately 400 terabytes of storage. So we are talking a lot of capacity here. So we need to focus on the storage server capacity. And early on in our development, we ran into challenges with our Hadoop and Talent environment capacities, and we had to take a step back, review all of this, and then work on right-sizing the environment. So it's pretty important to keep in mind and lay out all of these foundational aspects that I talked about. Think about the requirements or how we are going to deliver, and considering the data quality, infrastructure, and all of these key areas need to be in mind before we start to jump into solutioning. And these are the key challenges we thought we will share with you all today. And with proper planning and mitigation, we will expect a fewer roadblocks. So these can also save us, like I said, time and optimize our investments. And as you all know, a program of this size, it requires continuous learning and improvement, and we are continuously learning and trying to improve upon the challenges that we have faced. So with that, thank you all, and then I give it back to David.
Well, great, thank you very much, Shobha, and Mike and Raj. Boy, it's a fascinating technology. We'll invite you all on the screen. Thank you for taking us through that journey, especially from the leadership position that Southern California Edison demonstrates in your, not only in your territory, but on a North American, in fact, global basis. It's great to share this information. But just reflecting as we're going through this whole discussion and where it all comes from, the grid being originally created to be a one-way road. You generate, transmit, and distribute the electrons, and that's the way it worked for 100 years. And now that you have to keep on the right path. At the same time, you've got all these other elements that are coming in, and how do you manage it all? It's very complex. Mike, we appreciated you starting off with some of the regulations you were speaking about. I noted that, and I wasn't aware, it's just my personal knowledge in terms of solar on all new construction as of like now in your territory, and 50% of renewables by 2030 and zero carbon renewables by 2045. On the grid, you're integrating your distributed energy resources into all of your planning and operations. You described that. You talked about the vision and tools that you're going through in terms of grid automation, energy planning tools, grid operation tools, communication upgrades, and enhanced cybersecurity. That's a daunting task. We heard about some of the benefits that you're starting to realize in terms of safety, reliability, decarbonization, wildfire resiliency. That's very important, obviously, where you folks are coming from, and some of the challenges that have occurred out west. Customer empowerment and economic efficiency. And then Raj, you talked to us about a lot of the tools, the engineering process and planning and tools, and love the portal that you described. And then Shobha, you actually answered one of the questions that came in while we were going through it, and that was, what are some of the key lessons that you're learning? And just noted, things like the recommendations: selecting the right technology, early prototyping, create data quality dashboards, integrated environment management, and finally identify the data requirements up front. Those are some key lessons for sure. For our viewers, we'd encourage you, should you have some questions, please go to your panel, type them in, and time permitting, we'll look to try and get to your questions. And to Mike, Raj, and Shobha, we do have some questions that have come in, and maybe we'll just start with the first one, and it's, if you were doing it all over again, what would you not do? Just throw that out there.
Well, I'll start us off, and I think it's a little bit implied in Shobha's presentation. A lot of the great recommendations that we're proposing were lessons learned the hard way. So we probably started with a little bit too much of a waterfall approach to system development. We tried too hard to anticipate all the right requirements, all the right data quality issues, instead of coming up with clever ways of forcing early discovery and really working with early iterations of the solution. That is just a much more powerful way to get to the right answer than folks sitting in a conference room on a whiteboard. So that would be one that would jump off the page for me. Shobha, Raj, any other items you'd like to add?
Sure, yeah, thanks, Mike. So I think whenever anybody talks about grid modernization, the first things that come to their mind are the advanced algorithms, the fancy stuff that you want to see on day one. But what we also kind of stumbled upon later, and what most people forget, is to get there are a lot of steps that need to take place. Like Shobha alluded, that we have a lot of foundational work, whether it was the profiles or whether it was the network, that needs to be taken into consideration. Our focus was a little bit lacking there. We were still targeting to hit the main advanced algorithms without much focus on the data and the kind of quality we need there, the basic building blocks, before we can get there. So I think that is something maybe we can change a little bit. And I think Shobha already spoke about this. This is an evolving journey. Even from the engineering side, we have noticed that they do not have a very clear picture of what they want on day one unless they look at something. So that is again the process change that Mike and Shobha both kind of pointed out. How we get there in slow iterations, multiple iterations, that will help us be more efficient, even though at the onset that may look very inefficient. Yeah, thank you.
Great, thank you very much. Next question. Some interest in the distribution resources portal. What's the technology behind the distribution resources portal?
Yeah, it's a good question. It's using ArcGIS Online right now on cloud to render the maps, whereas we have like JavaScript and .NET behind the scenes with Oracle databases to provide all the data necessary to render on the ArcGIS maps. Yeah, there's been a lot of changes. Yeah, go ahead.
So I'm sorry, this is a custom solution as opposed to an off-the-shelf solution?
That's right, yeah.
Thank you. Thank you. That's great. Thank you. Next question was, what's the status of smart meter installation at Southern California Edison?
I'll take that one, as that was the program that I was on before I started with Grid Modernization. We've deployed, we're fully deployed in terms of smart meters, both in terms of our residential and commercial customers. So the larger commercial and industrial had that kind of advanced metering ahead of time, but we have deployed during the period of 2008 to 2013, we deployed 5 million plus smart meters across our residential and commercial customer base.
Yeah, 5 million, but who's counting? That's a significant job. Wow.
Only 10,000 a day. Well, yeah, who's counting?
Wow, well, that's big. Next one, Shobha, over to you. How are you mitigating data quality issues to meet your goals?
Yeah, so that's a challenging area that, like I described, we are deploying two-pronged approach there. One is we have a data quality management strategy. So outside of the GridMod program, IT and the T&D business, we teamed up, partnered up, and we manage the data quality issues by identifying first, and then prioritizing all of the data quality. And we closely work with the business to close out those gaps, whatever the solution may be. Like I said, either business process gaps or whatever that gap may be. So we have that going on. It's an ongoing strategy and a teamwork there. And then as far as GridMod goes, what we are doing is we're trying to get some of our prioritized data quality issues into that a bucket, if you will, and try to address there. And if not, we kind of looked at our solutions to build that gap in with respect to the data quality. So a two-pronged approach we are deploying, like I said.
Great, thanks. Any challenges from a business case perspective of putting forward your case for the need for these solutions?
Yeah, that is always a challenge, right? Because there are GridMod priorities, and then there is the other business priorities. So it's a matter of negotiation and working with the business to have that balance, right? What is high priority for the rest of the T&D, and what's the priority for GridMod? So it is a negotiation, and it is a work in progress. Mike or Raj, would you like to add anything there?
Yeah, it's been an interesting story to follow over the years. You know, when the California Public Utilities Commission published their requirement that each of the utilities file a distribution resource plan, this is kind of this 2016 period generally. The spotlight was really on Grid Mod. Now we have wildfires. Now we have implications of where we are with COVID. There is some pretty big issues on the radar of our executives, and I think it's kind of asked us as a program to make sure that we have a very focused business case story to tell that is still very relevant and is still very much part of the longer term plan in particular, even if some of the short term focus needs to be on wildfire, for example.
Yeah, no, that all makes sense. Next one up, Raj, this is probably you. What technologies are you relying on for analytics-based capabilities?
That's a very good question, Dave. So it's also an evolving journey that we have learned in the process. So I'll just leave it at the high level. We are using kind of a two-phased architecture where we have a huge big data lake. It's kind of a architecture behind the scenes where we run most of the algorithms overnight, while at the same time we are using Hadoop for that. While at the same time we need a lot of user interactions to review those profiles, look at the network connectivity. So we are using SAP HANA with a visualization layer, so that on one hand we have the heavy lifting being done at Hadoop for all the machine learning and data algorithms, while in HANA we are using slices of that data for visualization. And then we have a bunch of engineering tools that is tied as bolt-ons to these analytics space.
Great, thank you. Next one up, Mike, probably over to your way. How are you building synergy between grid modernization strategy for operations, engineering, and planning?
Yeah, this gets back to something that I focused on in my portion of the presentation, really around the fact that Grid Mod is bigger than the engineering and planning tools. We have this big operations piece to it as well, and it's an interesting question because to some degree those programs, those set of investments can proceed independently. There is some independent dynamic to it. However, there are key touch points. One of them we've already talked about, which is data quality. Data quality can transcend both the engineering and planning tools as well as these grid operating tools. Another one is actually more direct. The fact that some of these solutions, the grid connectivity model, the forecasting capability, while the operating systems really utilize short-term forecasting, that's a core capability there. The long-term forecasts that Raj has been describing still are a feed into these operating tools. The grid connectivity model is a key solution, that network model that feeds into these operating tools. And then one other tool that we didn't really spend much time on is the grid interconnection processing tool. So this is the tool that allows interconnection applicants to have an online, very streamlined way to apply for interconnections and to feed their data into a system that can manage that data and become the system of record for that data. That DER data also feeds into the operating system. So there's a few very key leakages where our operating systems have significant dependencies on these planning tools. And then the final point I'd make there is that, again, in terms of, and we kind of touched on this, in terms of executive messaging and public messaging, the Grid Mod story, the Grid Mod business case in total is greater than the sum of the parts. So being able to articulate that at the program level is, I think, really powerful and could be lost if we're just talking about engineering and planning tools or just talking about cybersecurity. So that's something that's kind of on the leadership team to make sure that that focused, holistic message continues to be articulated very well.
Great, well said, thank you. Just noting the time, we're coming up to the top of the hour. Apologies to those other questions that we weren't able to get to at this point. So with that, Mike and Shobha and Raj, you can turn your cameras off now. Thank you so much. We'll just do a quick close. Thank you again for your time. And a reminder to our viewers that our next Corporate Partner Conversations series webinars will be held on October the 27th. Where Infosys will be back again with Arizona Public Service, and APS has about 1 million customers, so a sizable operation. We'll be presenting accelerating customer engagement through digital transformation. And then on October 28th, the next day, Stephanie Axman will be presenting Indigenous Rights in Canada, a review of significant legal and constitutional milestones. Please note that all of CEA's events and webinars can be found in our monthly newsletter, Current Affairs, or you can go to the News and Events section of our website at electricity.ca. And with that, we'd like to thank you again for joining us today, and until next time, bye for now.